Good morning, everyone, and welcome to this talk on AWS Lambda. My name is Yan Cui, and I'm an engineer at a company called Space8 Games. We are a game studio based in London, and we make some award-winning games such as Transformers, Earth Wars, and Rival Kingdoms. And our latest game, Fastlane, has also been nominated for this year's Tiger Award. We're also hiring, so do with that information as you will, which is why the company gave me time to come here and do this talk. On a more personal note, I've been using Amazon Web Services since about 2009. And before joining Space8 Games, I was working in the social networking with a startup called Yabbo, which you can think of as a mix of Instagram, Facebook, and Twitter. And it was there that I did a lot of work with Amazon Lambda. Me and my team, we learned a lot about how to operate Lambda in production at scale. And when I joined the company, Yabbo in that case, I inherited a pretty standard monolithic backend system with a few components, which looks very simple on paper. But as you peel away each of those boxes, you find a lot of hidden complexities and dependencies. And one of the interesting thing about our social network is that being a very early stage social network, we didn't have that many users, but we had a few very powerful users that has tens of thousands of followers. So whenever they would run a campaign on our platform, you see a massive spike in traffic, sometimes up to 50 or 70x of the normal the traffic we see. And because everything was running on EC2, so you're paying for a lot of unused CPU cycles, and because scaling up with EC2 is very slow, it takes, 10-15 minutes to get a new instance running and serving requests. And because of the spikes we tend to see as well, which means we tend to have a lot of spare capacity lying around just to handle those spikes. And our deployment was not in a very good place. They tend to take some time between 30 minutes to 45 minutes, and they require downtime as well. So all of that is just not very good, especially by today's standard. One of my favorite speakers, Dan North, once said that the lead time to someone saying thank you is the only reputational metric that matters. And it's a message that has resonated with me and has stuck with me ever since. And to get that thank you from someone, you have to first provide some value. And to do that, you need to ship your software. Until your software is shipped and working and running in production, as far as our users are concerned, we haven't done anything at all. So looking at what we had, we know there's a lot of problems. We need to address them. Maybe we have to do a lot of re-architecting and rewriting things from the ground up. But we can't hope to build something better unless we can measure what is good. So before we go away and start writing code, we sat down with everyone in the team, including the product guys, to come up with a list of things that would define what good looks like for us. And we came up with a list of criteria that I think it must be very familiar to many people now, that we want deployment to be small, to be fast, and the deployment shouldn't require any downtime. And we absolutely do not want to do lockstep deployment with the client because of the sheer amount of coordination required. And we want features to be loosely coupled, and they should be deployable independently so that different components of your architecture can evolve at their own pace, where if everything is really tightly coupled, then you end up in a situation where everything has to evolve at the pace of the slowest moving component, which is not a place that we wanted to be in. And from the operational side of things, we want to cut out a lot of fat that we had in our AWS build, and we want to minimize the amount of time we spend just babysitting our infrastructure. We also had lots of technical mess to deal with, and I chose the word mess very consciously because where a lot of people talk about technical debt, that implies that you have made a conscious design decision to take out some debt somewhere with a plan to eventually pay it back. What we had wasn't that. What we had was, by all imagination, is just really badly designed the components. And whilst we try to address all of this mess, we still want to deliver value to our customers. In fact, we want to do it faster than we've ever done before. So all of this is pointing us to a very different style of architecture. And fast forward a few months, we arrive at a place where we had architecture that is event-driven, and service-oriented, and Lambda was the centerpiece that glued everything together. At this point, we had over 170 Lambda functions running in production. And from a cost point of view, we were making a 95% cost saving for the same amount of compute that we were doing on EC2. In terms of the release cycles, it also happened far more frequently, going from about 4 to 6 releases per month in April when I joined the company. by September or October time, we were doing roughly, I think, 80 or 90 releases per month. And this also changed the way how we work with the product team, having been used to the previous team where everything was just so hard to move, really hard to do things. So rather than telling the team what it is they want to build, they tell you as an implementation, a workaround that they think you can deliver in a reasonable amount of time. So having seen how fast we can move, that dynamic has changed. And now they're coming to us about what it is they want to actually build. And we work with them to make that happen. And for the moment, we decided that Lambda is a good fit for what it is that we want to achieve to be able to run the first function in production. We have answered a lot of questions around how do we do continuous integration and deployment, how do we go about testing all these cloud-hosted functions, and what about all the operational concerns that normally comes with operating software and making sure that it's up and running, the logging, monitoring, and so on. And as our architecture expanded to include more and more services, and for services to start depending on one another, there's a whole bunch of other questions that we then need to answer around distributed tracing, and how do we manage configurations across all of these functions, and how do we keep our credentials and all this sensitive user data secure and safe. So I'll try to answer many of these questions as best as I can, but for now I want to talk about some of the things that we actually done to give you a frame to consider those challenges that we're going to be talking about later. So when I joined the company, the app already has a search feature. At the time, it was just one big regex query against MongoDB, which, as you can imagine, didn't perform very well. In fact, we struggled for performance at about the 100,000 user mark. And it was really hard to do rudimentary ranking with the implementation that we had. And one of the first things we did as part of our migration from to Lambda was to make sure that our legacy system is publishing state changes as events into Kinesis streams, so that we can now hook up a Lambda function to process those events. And whenever a new user joins the platform or updates their profile, we will update user index in Cloud Search, which we can then expose as an API using API Gateway and Lambda, so that you have now a search API that you can hit. And because we were moving faster than the app team was able to move, so at this point, we also proxy the existing legacy endpoint to hit our new API instead, so that we can deliver these improvements right away without having to wait for the client teams to also catch up. And we also didn't have an analytics pipeline, and we were very much constrained by what we were able to do with Mixpanel, and not to mention how expensive Mixpanel was for us. So to do that, we built a brand new pipeline using Kinesis events and consuming them with a Lambda function that will live stream those events into Google BigQuery. And this was before Athena was announced. And at this point, I've already been using Google BigQuery for maybe 5-6 years, and had really good experience with that Google BigQuery, which is why we made a decision to use that instead of say Redshift. This project took quite a few cycles, but the first iteration of it took less than 2 days to go from initial discussion with the product owner to having something running in production that they can use. And it was done by one developer, and that was the first time he actually worked on a Lambda with the serverless framework. And at that time, our BI guy actually came to us afterwards and said, "God, thanks, guys. No, nothing ever got done this fast as Skype." He has just joined us from Skype, which is, well, obviously no offense to Skype, but it goes back to the point that we should optimize for the lead time to someone being to say thank you to the good work that you've done. And as we got more comfortable with running and developing with Lambda functions, we started to tackle other more complicated parts of our architecture. We had the timeline feature very much like what you find in Twitter. Our implementation was really complicated. It was really hard to understand. I kid you not, there was one event processing part of the system that was using files named 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and try to understand what the hell is going on here. It's just, and it was so unreliable and bug-ridden. There was a well-written spec on how the feature should work, and the QA team had a whole list of criteria to test it, and all the tests failed, to the point that the QA team just declared this whole feature untestable. And by this point, the new CTO had come in and fired everyone who has put the system together. So we decided to go back to the product team to understand what it is they want to do with this feature. And we build it from the ground up, again, by using events that are coming from our legacy system. Whenever you create a new post, you start something, or you retweet something, or whenever you follow or unfollow other users, those events are then handled by a bunch of Lambda functions. In the case of you posting a new content, you work out, okay, where this post should go based on your followers, and then you group those followers in batches, I think about 100. For each one of them, send a message to SNS, which are then handled by another Lambda function that would then add that post to your user's feed, which is stored as a Redis sorted set. The reason we are proxying through SNS is so that we can leverage the parallelism you get with SNS, but also the retry mechanism you get out of the box as well. And to allow users to fetch the timeline, we have another new API that's backed by API Gateway and Lambda function, and we proxy the legacy endpoints to hit our new APIs so that we can keep moving and provide value to our users without having to wait for the app teams to catch up. Being a social network, we also had the recommendation feature, similar to the ones you find in LinkedIn and Facebook and pretty much all the other social networks. Our works slightly different though. Unlike those other social networks with their complicated and fancy algorithms, we just return the first 30 users from a database via account creation time, which, as you can imagine, just not useful to anybody at all. So we went about rebuilding from the ground up. This time, again, we're using a cron job, which is basically a CloudWatch schedule event to trigger a Lambda function. Since we have all the state change in Google BigQuery already, so we can run an ad hoc query to find out who are the trending users on the platform based on how many people have recently followed them, how many people have liked or retweeted their post. And we say that into DynamoDB so that you can have a trending API for you to find out who are the current trending people. And every time you follow or unfollow somebody, those relationship changes are also processed as events and used to update a social graph stored in GrapheneDB, which is a hosted version of Neo4j, a graph database, which allows us to very easily and quickly do query based on your second or third degree connection. So those are the people that are followed by the people that you follow, for example. And we expose that as an API, and we also proxy the legacy endpoint that returns the list of recommended users for you to hit these new APIs instead. And that's tend to be our strategy for migrating to new services in a graceful way. And that's just some of the work that we were able to do very quickly, whilst we also address some of the operational concerns that comes with running Lambda functions in production, which we're going to talk about now. The first thing I would say is that you should definitely choose a deployment framework to take care of all the heavy lifting for you. The one that we use was called the Serverless Framework. The reason why we chose it is because it has a company behind it. They are well-funded with full-time people working on the framework. And already at that point, they had a lot of momentum. And they also have a multi-cloud support as well. So even though the syntax is slightly different, you can ultimately use the same tooling as you move from one provider to another. And for the same reason that Terraform is great, even though you are using different syntax when you're talking about Amazon Web Services versus Google Cloud. Nowadays, Amazon also have got the SAM framework as well. And then there's the Apex. I think a lot of people use that. And from the creator of Apex, there's also now a new framework called the UP. And then there's Cloudia, Zappa, Sparta, and there's a whole bunch of them. I guess the point is that it doesn't really matter which one you choose. Do have a look, shop around and see which one works best for your flow and for your requirement. The thing I would mention is probably that whatever you choose, try to be consistent and stick to the same ones for your team. Otherwise, when people move around from one project to another, you don't want to be in a situation where they have to learn 4 different deployment frameworks, 4 different set of syntax and the caveats for different frameworks. Just try to be consistent with whichever one that you choose. And once you start writing Lambda functions, you're going to have to figure out how to test them. And as far as testing goes, this is my favorite book, a book by the Ned Price and Steve Freeman. You can find them on Amazon, where they talk about the different levels of testing. You have your unit tests, where you test at the object level to see how they interact with other objects. And you can still do that with Lambda. Ultimately, it's just code. You can still write your unit test the same way as before. And then there's your integration test, where you try to test your code against the code that you can't change. And since Lambda ultimately is just a function that Amazon is evoking when some event happens, so you can still test that by invoking your function code with a stub, the event, and context object. Because the point of an integration test is to test how your code integrates with other systems. So I would say that when you run this integration test, you should configure your function to hit the real downstream systems rather than local mocks or a local environment. And then you've got your acceptance test. This is where your Lambda function has been deployed to a live environment, and you're trying to run things and test them end to end to make sure that everything is working together correctly. And so you go up this triangle of there's the different levels of testing. At the top, you've got a unit test where the feedback loop is a lot faster, and developers love that. But as you go further down the bottom, you get more confidence that whatever you're writing, the code you're writing, is actually going to work when you deploy it. And one of the things I also learned from this book is that you shouldn't mock the types that you can't change, because, and I'll quote, "We find that tests that mock external libraries often need to be complex to get the code into the right state for the functionality we need to exercise. This means in such tests is telling us that the design is not right, but instead of fixing the problem by improving the code, we have to carry the extra complexity in both the code and the test. And also that we have to be sure that the behavior we stub or mock matches what the actual library is going to do. Even if we get it right once, we have to make sure that the tests remain valid when we update those libraries." And I think the same argument, the same principle applies to this increasingly service-oriented world that we live in, that we really shouldn't be trying to mock services that we can't change, that we don't control. You might argue that, well, that's going to lead to a lot of chaos because everyone is deploying to integration environment and running their tests and getting into each other's way. Yes, that's true. But I also argue that that's what those environments are for. What's the point of having all of your tests passing, only to find that the moment you release it into production, something else happens because you didn't account for the fact that someone else is making some other changes. You want to catch those problems early in your integration environment. The guys also then went on to talk about testing end-to-end, that an acceptance test should exercise the system end-to-end without directly calling into its internal code. An end-to-end system should interact with the system only from the outside through its interfaces. So for the search feature we talked about earlier, to run the acceptance test for this system, we will create the test conditions by interacting with the legacy system via HTTP, the same way that the application would do. And then we'll validate the conditions so that when a new user joins the platform, so we create a new user via the legacy system, at some point after all these events being processed, that new user should be searchable via the search API that we have just created. And soon, once you've got your code running, you've got your tests are passing, you want to deploy your code, you need to start thinking about how you're going to do that continuously. And with the CI and CD, I find there's often a temptation to leave it to the very end of the project. But since it's a mechanism for saving you time and prevent human error, I think there's an argument for you to consider CI CD a lot earlier in your project. And again, going back to the same book, the guys talked about how we prefer to have the end-to-end test exercise both the system and the process by which it is built and deployed. This sounds like a lot of effort because it is, but has to be done repeatedly anyway during the software's lifetime. And this brings me to one of my, I guess, pet annoyances, whereby you have all these custom deployment steps that are only captured as scripts on your Jenkins box and not source control anywhere. And eventually someone's going to try to make a change, it's going to break it, and you don't have source control to tell you what happened, who made a change, why did it do it, and more importantly, what was there before, so that you can easily roll back. So for that reason, every one of our projects have a very simple build script, which just provides a very thin layer on top of what NPM and the serverless framework give us already, and allows us to orchestrate the deployments as well as running acceptance tests and all the different tests as well. And thus, well, I'm really bad at writing bash scripts, so everything I write is very that simple. All it's doing is when you provide a command, you call the bash script with the deploy command with argument. You would then just install the dependencies and then use the serverless framework to do the actual deployment to your AWS environment. And since it's just a script, it means that you can run it locally, and you'll run the same way as it does when it runs on the CI box as well. For continuous deployment versus delivery versus deployment, we were doing continuous delivery, whereby the deployment to production is a manual step, but that just involves someone clicking a button in Jenkins, but at least give us some control so that we can let the QA team do the manual testing. We haven't automated all the testing at that point. Once the code has been promoted to the staging environment, but all before that is all automated. The deployment, you go through all your unit tests, integration tests, you deploy the code, you run the end-to-end test after that, and then you promote that to the next environment and so on. We don't deploy on Fridays because we also have drinks on Friday, and drinks production release doesn't quite mix. And then we have logging. Whenever you write to standard out in your Lambda function, that gets captured by the service and it ships to CloudWatch logs asynchronously for you. So there's no overhead for your function's invocation time. And you also get some additional bits of information, such as the unique ID for the invocation, as well as a timestamp. And you can find all of your logs organized inside CloudWatch logs based on the function version and function name and time and so on. But it doesn't make it very easily searchable, and this becomes an even bigger problem as you add more and more Lambda functions. And it's a common problem that people have in microservices, and the approach there is to aggregate all of your logs in one location and make sure that they are easily searchable. And nowadays, the sort of de facto stack is the Elk stack with Elasticsearch, Kibana, and Logstash. And when you're running in the for Lambda functions, you can go to CloudWatch logs. You can choose to stream all of your logs to Elasticsearch service, the Amazon hosted version, directly. Or if you don't want to use the Amazon hosted version of Elasticsearch, you can also have your logs streamed to a Lambda function, which then you can process and send to maybe a self-hosted Elk stack somewhere, or some other provider that you're using, maybe Splunk or maybe someone else. Excuse me. But since every function you create also creates a new log group, so you don't want to have a manual process to subscribe every new log group to your log shipping function. So what you should do in that case is to enable CloudTrail. And once you've done that, you can go to CloudWatch events and create an event that targets whenever the create log group function is called, and have it invoke another function whose job is to automatically subscribe your new function, your new log group to your log shipping function. Another thing to keep in mind is that whenever Lambda creates a new log group, it is set to never expire logs, which obviously is not great. The cost is going to start to accumulate over time. So what you should also do is do the same thing, but subscribe to another function that would then automatically set the expiration time to something a bit more reasonable, maybe 7 days or 30 days. I've got some demo code that you can use with a blog post I wrote a while back. So I'll share the slides after the talk so you can go and look at it yourself. So having all of your logs in one place, easy searchable, that's all great. But as soon as you find your services now start to depend on one another, you're going to need a bit more help. This is the flow of what happens when you post a new content and to the content being added to your followers' feed. And suppose someone was to come to you that, hey, you've one of the guys I follow posted something. How come I didn't see it in my feed? And to try to understand, where this problem could have happened. It could have happened in any number of different places. And as is the case with production, there's just so many noise, it's very hard to figure out what exactly happened. And that's where correlation IDs is super useful. It allows you to string together all the related logs from all the different places in one chronologically to see exactly what has happened to that bit of a post that got created by the legacy system, all the way to it ending up in the followers' feed. And since these IDs need to flow through API calls, need to flow through Kinesis events, as well as SNS messages, it means that you also need to capture those contexts across all of those different event sources. And the way we approached this was to roll out our own client libraries by wrapping around our favorite HTTP client, as well as the AWS SDK client libraries for Kinesis and SNS and so on, so that whenever you call an API, you capture those captured correlation IDs are sent as HTTP headers. For SNS, you can send them as message attributes. For Kinesis, you don't have other ways to tag the message, so you kind of have to shove it into your payload. Again, I've got some example code you can play around with after the talk. Another aspect of distributed tracing is to sort of trace the performance and find out where the time is being spent in your function invocation. This is, again, a common problem that people have in microservices. And Amazon provided a solution for you out of the box called X-Ray, where you can enable it on your on a function, and then you can see all the different services that your function is calling, how much time you're spending in there. And from that information, you can also create a service map to see how the different services are linked together and where the sort of average and maximum time is spent there. There's one problem with X-Ray right now is that one of the problems with X-Ray right now is that those trades does not span over HPI gateway. I know Amazon is working on it, but for now it means that whenever you call another API through Lambda function, you won't see the drill down inside what happened inside that API. So it's useful, but there's some limitations right now, which ultimately means that it's probably not going to be as useful as it should be. Again, you can read more about that later. And for monitoring, one of the things we are used to doing is to install agents on our EC2 servers, statsd or collectd and all of that. But since we don't have access to the host anymore, we can't do that anymore with Lambda. So instead, we have to rely on what we get from the system, from CloudWatch. You get a bunch of metrics out of the box around the invocation time and invocation count and so on. And a bunch of other providers has also announced support for Lambda, but ultimately they are using the same underlying metrics you get from CloudWatch, but exposing it through a better-looking dashboard. There's a bunch of guys called Owlpipe. They do something slightly differently. They give you a wrapper library to sort of wrap your function code so that they're able to intercept the invocations and then send additional metrics to their systems. Obviously, there's a downside to this approach where it adds more latency to your function invocations, which is not a good thing for user-facing APIs. So I do have reservations about what the approach they have taken, but it's certainly a very interesting approach, and a lot of people are actually using this and have very good things to say about those guys. So try it out, see if it's a trade-off that's worth for you. Another thing we're used to doing with the servers is that we batch all of our metrics and logs, and we send them in batches behind the scenes in the background. But with Lambda functions, everything you want to do has to be done during the function's invocation, which means there's no background processing time for you to do these things. And that forces you into making some uncomfortable trade-offs between having loads of useful metrics to latency. There's a couple of ways to mitigate this trade-off. The best one I've found is how Datadog is what Datadog is doing to support custom metrics. Essentially, it allows you to write your metrics as specially formatted log message, which are then, as we talked about, gets captured and shipped to CloudWatch logs asynchronously. Those are the only background processing you're going to get is the other things that the system is doing for you. So this is one way to leverage one of those background processing so that you can then have your log shipping function to identify those and send those to your metric system instead of to your your aggregated log aggregation service. It's of course making you just make a trade-off between the liveliness of your metrics to latency overhead, and it's not the right approach for every scenario. So you should definitely try to mix and match different approaches. For user-facing APIs where you want to minimize the latency as much as you can, maybe consider this so that you minimize the amount of overhead you have for tracking additional metrics. But for background processing, where latency is not as critical, maybe you don't have to do that. You can just send logs, you can send metrics straight away. Again, I've got some examples that you can use in a blog post recently. And once you've got all of your metrics, do the usual things around setting dashboards and alarms and add any application level metrics as a custom metrics if you want. And whilst the CloudWatch is a pretty good and cost-effective solution, and in some cases it's the only way for us to get metrics from those managed services from Amazon, such as Kinesis, DynamoDB, and so on, there's some limitations with CloudWatch around both the UI as well as the granularity. Even though they have fixed a lot of that recently, now you can track custom metrics at a 1 second interval with CloudWatch, but the system metrics that you get from other managed services are still at the moment 1 minute granularity. And it also doesn't have some of the more advanced features like anomaly detection and projections and things like that that you find in other services such as Wavefront and Splunk. But for me, the biggest reason for not using CloudWatch as my primary monitoring system is that it has a tendency to go down at the same time as the services that you're using to monitor, which has happened to me a few times when Amazon had the networking issues and EC2 went down at the same time as CloudWatch. So I know there's a problem happening. I have no way to know what the sort of impact it's having on our customers. So that's not a great place to be. And for configuration management, I guess the main criteria for me for a system like this is to be able to easily and quickly propagate any config changes that I have. Nowadays, when you create a Lambda function, you can set environment variables. I think the UI has changed actually. They've recently updated the UI. You can also have KMS encrypt your environment variables as well. And this is an approach that we started off with, even though we were using environment variables in the serverless framework, because at the time, Lambda didn't support it natively. What we found is that as an approach, it didn't scale as we added more and more functions, especially when more and more functions have shared the configurations. There was one, we were using MongoDB for legacy reasons, and there was one time we needed to update our MongoDB connection string. So that was one painful week for one of our developers who had to go through all of our all of our functions to update that connection string, which is not great, right? You don't want people to spend several days just doing that kind of thing. So instead, what you should do is invest in having a centralized config service, and it can be something as simple as a key value store. So I had a look at the different solutions available there, including the popular choices such as Console and SCD. But I didn't really fancy these solutions because, well, firstly, they're quite expensive to run. You have to run EC2 servers all the time with maybe even with multi-region if you want to go with high availability. But also for each one of them, you have a learning curve as well for how to manage and configure the service, as well as all the tooling that comes with it. And not to mention, what we're going to need is going to be like 5% of what these products actually can offer. So at the time, we wrote our own config API because at the time, there was no SSM parameter store. But since then, Amazon has announced the SSM parameter store, and you should just use that from your Lambda function. It gives you a full history of config value changes, as well as the IAM control over who can access what parameters, and KMS integration as well. Another thing you should spend some time is invest into a good client library that can support the caching as well as hot swap. So if the source config value has changed, you don't want to have to redeploy the function to get it. You should just support that out of the box. Again, I've got another example that you can use out of the box in a blog post I wrote recently. I did a lot of blog posting recently. Another thing to keep in mind is that where you have sensitive data, they should be encrypted both in flight as well as at rest. And you should try to give them role-based access. And the KMS gives you both. And when you're using the SSM parameter store, you kind of get both out of the box anyway. So when you create a new parameter or when you update a value for a parameter, that happens you can do that via API calls or use the CLI command line tool. In both cases, it requires role-based permission to access them. And those parameters are then encrypted by KMS. And when you function and store the encrypted at rest, and when your function runs up and fetches those parameters at runtime, again, that happens over HTTPS and also is using role-based access as well. There's also some plugins you can find on the serverless framework where you can do that, but with the approach those frameworks and those plugins have taken, they didn't quite meet my criteria. So I still think the best way to do it is to fetch configurations at runtime and have them encrypted and use the SSM for the SSM parameter for that. Okay, so the last few minutes I want to just talk about some general tips and tricks I've learned. So if you're using the serverless framework, one thing to keep in mind is that AWS Lambda has got a regional limit of 75 gig for all of your deployment packages, which you may think is a lot. And when at Yabbo, we had a team of 6 people. We managed to rack out about 20 gig of deployment packages inside 3 months, even though every single function is only about 2 meg. But we are deploying so often, we're deploying sometimes 50 times a day per person. So those numbers start to rack up pretty quickly. And at the time, the serverless framework didn't have an option to disable this behavior of creating new version every time you deploy. So we had to find a solution to address this, and the solution I came up with was to take a leaf out of Netflix. They've got Janitor Monkey that goes around cleaning resources that I don't use anymore. So I wrote a Janitor Lambda function, which is essentially a cron job that goes around, that runs every now and then and scans all of your functions and check all the versions and find versions that are no longer aliased and deletes them. With the serverless 1.0 and above, there's also an option for you to just disable this behavior of creating a new version every time you do a deployment. And another thing you should do with the serverless framework is to install yourself as a dev dependency on your project. Since the 1.16.0 release, it automatically excludes any dev dependencies you have. And by installing the serverless framework itself as a dev dependency in the project, it means someone coming into the project can just use your batch script to do deployment without having to install the serverless framework as well. And also, if they introduce breaking changes to the framework, maybe a new major version upgrade, you don't have this case where, okay, I need to somehow run both the new and old version at the same time in order to deploy your code, so that in this case, you're locking the version of serverless framework with the project. And serverless framework also has support for you to invoke your function locally using the invoke local command. And if for Node.js and Python functions at least. And if you're using Visual Studio Code, you can also hook up a debugger to this command so that you can essentially locally debug and debug your Lambda functions. Amazon also announced SAM Local recently, which is a way for you to sort of simulate local environments so that when you deploy a Lambda function from an API, you actually have a localhost endpoint that you can hit. You can also use the serverless framework in conjunction with SAM Local as well. And when it comes to performance, one of the key things to remember about performance is to understand COLDSTARTS. So the first time when you invoke your function, if you look at it in an X-ray, you can see there's some uncounted time at the top there before your function code actually runs. That involves, so that's what we normally call the cold start time. Amazon hasn't gone into detail on what constitutes the cold start time, but the IBM guys, IBM OpenWhisk guys has. So you can pretty much assume Amazon is doing the same thing, where the cold start time is the time it takes to start a new container and then to also initialize the runtime before it's able to invoke your function code. I did some experiment before to see how long Lambda keeps your idle functions around. So if a function is not being invoked, does the container live around for a while? And what I found is that the time is typically about 45 to 60 minutes before an idle function is then terminated. And even if your function is actively being used, it's only kept around for about 7 hours. So even for active function, you will still see a cold start time every 7 hours or so. Again, these are implementation details that it's good to understand the behavior of the platform, but you shouldn't build them into your application as hard assumptions. I think we're running out of time now, so I'm just going to skip to the end. Some nice pictures. So maybe I'll just talk about this briefly. That one of our, coming from a sort of statically functional programming language background, I'm a big F# programmer and love types. One of the things I learned is that with Lambda is tackling the problem of complexity from a different angle. If you write your Lambda function in C# or Java, your cold start time is I think 2 orders of magnitude higher compared to Node.js and Python. And as far as type safety goes, I mean, I'm one of the guys that's been going around to different conferences, telling people about using types to make invalid state unrepresentable in your domain. But what I find is that with a typical Node.js application, the sort of ceiling from complexity is really, really high. And all the things that I love about F# is really tools for me to help manage that complexity. And with Lambda, because you're putting the developer into a very constrained environment in terms of what they can write, what they can do, it actually limits it really limits the amount of complexity that you have in a single function. So even without all the tools I'm used to and I love from F# and other static type languages, I haven't missed them very much when I'm working with Lambda and writing my code in the Node.js. So I think that's 40 minutes. So I'm just going to skip to the end. Okay. What do you want to talk about? So I'm running a course with O'Reilly, a free course for Safari books online that you can sign up to. The links there you can find on the slides as well, where I'm going to be talking about a lot of focusing on how to address the operational concerns with running Lambda function in production. It's a 6-hour course that pretty much contains everything I've learned with Lambda in the last 2 years. So if you've got an account with Safari Books Online, you can sign up for free, or you can sign up for a free 10-day trial. I think by October the 3rd, you can get the course for free as well. So with that, I think over time, I'm sorry. So yeah, 41 minutes. We still have 4 minutes for questions, if anyone has any questions.
Anybody want to say anything? Do you want to go on and say something?
Do I want to go and say something? Do you guys want me to go on to talk about things I skipped? Or do you want to go and have some popcorn or something? Okay, let's leave it at that. And if you guys want to go any more questions, I'm going to be around for the rest of the day. So feel free to just come and grab me if you've got any questions. Thank you.